Good day. This is Group 1.
I am Catherine Castro.
Kramer Gutierrez.
Leonard Serena.
Janelle Figueroa.
Lisa Cadilla Bancos.
Redon Villanueva.
And I am Isa Bergilius.
We will present to you atomic size and ionic radius. And for the atomic size or atomic radius, we have Catherine to explain the definition.
In chemistry, an atomic radius is defined as the distance between the atom's nuclei and the outermost shell of the atom. These atoms are neutral and particularly hold stable electrons. Say, for example, we have a hydrogen atom's illustration. The dot you see in the middle is called the nucleus, and the line highlighted by white and red is called the radius. So, by definition, a radius is a straight line from the center to the circumference of a circle. The unit to express atomic radius is picometer or pm, that is equivalent to 1 times 10 raised to 12 meters. But when it comes to two adjacent metal atoms or a diatomic molecule, the atomic radius between the two nuclei is half of the actual distance. Say, for example, we have hydrogen gas here, tapos we have the given distance of 74 picometer. Since ang radius ng isang hydrogen atom ay distance divided by 2, we divide 74 by 2 and we get the answer of 37 picometer.
And for atoms linked together to form an extensive three-dimensional network, and as illustrated here, this is an example of beryllium, a metal. Atomic radius is simply one half the distance between the nuclei and two neighboring atoms. And as you can see, the arrow signifies the distance. For elements that exist as diatomic molecules, and in the example, we have the hydrogen gas, or H2. The atomic radius is one half the distance between the nuclei of the two atoms in a particular molecule. Another example of the atomic molecules are nitrogen gas, chlorine gas, oxygen gas, iodine gas, chlorine gas, and bromine gas. And the other, which is a simple compound, carbon monoxide, and many more. And to explain the periodic trends of atomic radius, we have Leonard.
The periodic trend of atoms regarding their atomic and ionic radius. So understanding the periodic trend of atomic and ionic radius of atoms is quite easy because they have the same trend. So let me first discuss the periodic trend of an atom with its atomic radius. So as you can see in the slide, the atomic radius of each element is increasing from right to left and increasing from top to bottom. So the reason why the atomic radius is increasing from right to left is because of the effective nuclear charge and the electron shielding. For example, lithium has an atomic number of 3, so its protons and electrons are also 3. It has 2 electron shell or orbital because it belongs to the second period. The nucleus, which has a positive charge, pulls the inner electron shell because they have different charges. The question is why the electron in the outer shell is not attracted to the nucleus. So it's because of the electron shielding. When we say electron shielding, it happens because the inner shell prevents the attraction of the outer shell from the nucleus kasi nga they have the same charge. So it repels, causing it to expand. Kaya naman, mas bigger yung atomic radius ng lithium compared to beryllium na katabi niya is because of the effective nuclear charge. Si beryllium kasi, it has 4 protons. Kaya mas na-attract niya yung electrons, causing it to shrink. So this is the reason why the atomic radius of an atom increases from right to left and increases from top to bottom due to electron shielding and effective nuclear charge.
And here is an exercise to better understand the concept of atomic radius. In the periodic table, when we move from left to right, the atomic radii A increases, B decreases, C constant, or D becomes 0.
The answer is B, it decreases. Kasi when the valence electron is added, tapos the protons are increasing, yung electrons ay magpo-pull together closer to the nucleus, which makes the size of an atom smaller.
Select the atom that has the largest atomic radius. A. Arsenic. B. Phosphorus. C. Sulfur. Or D. Selenium.
The answer is letter A, arsenic, because as discussed by Leonard, the atomic size increases when going from right to left across a period, and then the atomic size increases when going from top to bottom. And yung pwesto ng arsenic sa periodic table, siya yung nasa pinaka-left at pinaka-bottom compare dun sa ibang choices.
Atomic radius increases because of A. Nucleus. B. Proton shells. C. Electronic shells. Or D. Neutron shells.
The answer is C, electronic shells, simply because the gain of an electron adds more electron to the outermost shell that is further away from the nucleus.
And now, we'll be explaining the concept of ionic radius.
An ionic radius is the distance between nucleus and electron on the outermost shell of an ion. First, an ion is electrically charged, tapos it has two types, the cation and the anion. The cation is positively charged ion and it has more protons than electrons, opposite of an anion kasi an ion has more electrons than protons kasi it is negatively charged. An ionic radii is half the distance between the atomic ions in a crystal lattice. Sa crystal lattice, may arrangement ang mga ions in a three-dimensional space, and the addition and the removal of an electron can affect the size of an atom.
Ionic radius for an atom is measured in a crystalline lattice. Consists of three-dimensional patterns, which has something to do with the X-ray diffraction. X-ray diffraction refers to the scattering of X-rays by the use of a crystalline solid. Scattering or diffraction produced are used to deduce the arrangement of particles in the solid lattice. So, X-ray diffraction experimentation is discovered by Sir William Henry Bragg and William Lawrence Bragg. X-ray diffraction is a technique or a method that is used for characterizing crystalline materials. And diffraction also defined as the use to measure the difference or the distance between the atom.
To add sa ionic radius affects the physical and chemical properties of an ionic compound. For example, the melting point and the lattice enthalpy. As we can see from the table, yung melting point ng ionic compound, kapag mataas yung melting point, bumababa naman yung radius. Sa lattice enthalpy naman, kapag mataas yung ionic radius, yung enthalpy ay bumababa. Dahil kapag mataas yung ionic radius, yung bond ay weaker.
So, for the main concept ng ionic radius, based nga dun sa diniscuss ni Catherine kanina, radius is the distance between the nucleus and the electron in the outermost shell. But for this case, since ion, it is the ionic radius. Tapos, the trends observed in size of ionic radii is due to the shielding of the outermost electrons. Na-discuss na siya ni Leonard kanina, yung about sa shielding. Basically, ang pinaka-concept ng ionic radius is when an atom loses an electron to form a cation, positive, the lost electron no longer contributes to the shielding of the other electron from the charge of nucleus. Thus, the electrons are more strongly attracted to the nucleus. Kaya, yung radius ng atom ay mas maliit. Tapos, when an electron is added to an atom, it forms an ion, negative charge. The added electron contributes to the repulsion of the outer shell, resulting in the increase of size. To sum it up, anions are larger than cations because of the repulsion.
For isoelectronic ions, the size of the ion is based on the size of the electron cloud, not on the number of protons in the nucleus. But before that, let us know what the definition of an isoelectronic ion is. According to Lumen Learning, under the section of variation ionic radii, Atoms or ions are said to be isoelectronic if they have the same electronic configuration. Take a look at the example shown in the screen. We have an oxide ion, fluoride ion, neon, sodium ion, and magnesium ion. All of them have the electronic configuration of 1s2, 2s2, 2p6. How would we determine the one with the largest or smallest ionic radius? Since the protons and electrons are opposite charges, they attract each other. That means the stronger the nuclear charge, the more protons it has, the greater force the nucleus exerts on the outer negative charges. It brings the outer charges closer because we know that atom is mostly empty space according to Ernest Rutherford. The ion that has the most number of protons, which is magnesium ion, would be the one with the smallest ionic radius.
Periodic trend of atoms based on their ionic radius. So like I've said earlier, atomic and ionic radius have the same periodic trend. So the periodic trend for ionic radius is increasing from top to bottom. Example, lithium ion has a smaller ionic radius compared to potassium ion. This is because from top to bottom of the periodic table, the atomic number and number of shells increases due to the increasing electron shield. So it becomes difficult for the nucleus to pull the electrons. Finally, let's talk about the trend of ionic radius across the periodic table. The ionic radius increases from right to the left. For example, let's consider the elements in the third period. First, the cations. Sodium ion has an ionic radius of 95 picometer, magnesium ion is 65 picometer, and aluminum ion is 50 picometer. Second, the anions. The ionic radius of phosphorus ion is 195 picometer, sulfur ion is 184 picometer, and chlorine ion is 181 picometer. So, as we observe, the ionic radius of atoms is decreasing from left to right due to the increase of atomic number, and the number of shells remain constant because they are all in the same period.
And for our last exercise, what is the periodic trend of ionic radius? A. Increasing from left to right. B. Increasing from right to left. C. Increasing from top to bottom. Or D. Increasing from bottom to top.
So the answer is increasing from right to left. Because, as discussed earlier, the ionic radius of an atom increases as we move from right to the left of the periodic table.
Which of the following ions has the highest value of ionic radius? A. Lithium ion. B. Boron ion. C. Oxide ion. Or D. Chlorine ion.
Fluoride ion and oxide ion are isoelectronic species possessing 10 electrons each. Lithium ion and boron ion are isoelectronic species possessing 2 electrons each. Since in the case of oxide ion there is greater electron-electron repulsion and lesser effective nuclear charge, oxide ion has the largest ionic radius in this case. So the correct answer is option C.
The set representing the correct order of ionic radius is...
If you have your periodic table with you, please tignan nyo for better understanding. Diba sabi nga ni Leonard, from right to left, nag-i-increase yung size. Tapos, from top to bottom, nag-i-increase siya. So, pag chinek natin sa periodic table, ang sodium ay nasa baba ng lithium. So, it makes it bigger than lithium. Kahit nasa leftmost sila both. So, the order ng set nila ay sodium, then lithium. Tapos, when we check magnesium and beryllium, magnesium is nasa baba ng lithium. So, mas mababa siya kaysa sa beryllium, kaya nasa last ng order yung beryllium.
And that's it for our reporting. Thank you for listening, and I hope that you learned a lot.